So I'm gonna love you like I'm gonna lose
What's
you.
up guys, I am Nishit Tarantula on YouTube after a long time. Say hi. She's my budgie. And today I'm gonna make a video on do photons have momentum? Yeah, they do have momentum, and classical physics is not gonna help you with that. You have to go to the modern physics to derive the equation, and I'm gonna derive it. Come along. Alright. Photons do have momentum, but as I told you that classical mechanics, its equation of momentum, which says that momentum is the product of mass and velocity, is not gonna help. So we're gonna make another equation for the momentum of a photon. So for that, you need two equations. First, E equals mc squared, which is the most famous equation, and the equation which you get from classical mechanics of momentum, which is the product of mass and velocity. Alright, first of all, what you have to do, you have to multiply gamma, which is the Lorentz transform after mass. So it will be E equals m naught. M naught is the rest mass times c squared over square root of 1 minus v squared over c squared. It is commonly known as E equals gamma m naught c squared. And same with the equation of momentum. Momentum is equals m naught v over square root of 1 minus v squared over c squared. Next step says that you have to square every term, so you'll get e squared equals m naught square c raised to the power 4 this square root will be no more existing. It will be 1 minus v squared over c squared. And same with momentum. Momentum squared is equals m naught square v square 1 minus v square over c square. Solve them a bit. It will be e square equals m naught square c is to the power 4. Then taking c square here, it will give you c square minus v square. And same with the momentum square, m naught square v square over c square minus v square over c square. Now, to make it a little bit more better, m naught square c, if we take the c square above, then it will be 4 plus 2 c raised to the power 6 over c square minus v square. And again, same with the momentum square, it will be m naught square v square. By taking the c square above, you'll have c square here, and c square minus v square. Now we have to multiply this e square by the denominator. We will have e square c square minus e square v square is equals m naught square c6. You should know algebra for this. And for momentum square, you have to again multiply this b square by c square minus v square. You'll have b square c square minus b square v square equals m naught square v square c square. And now we need the equation for this term, e square v square. So it will be e square v square equals e square c square minus m naught c raised to the power 6. Sorry, m naught square times 6 raised to the power 6. And for this one here, you need the value of b square c square. it's gonna be b square c square equals b square v square plus m naught square v square times c square. Now we need here what the value of v square, so the equation will be v square is equals e square times c square minus m naught squared c raised to the power of 6 over e square from here. And here at this place we need the equation for alright, here we have to take this v square as common, so it will be b square c square equals v square, we have taken this both the v squares as common, times m naught square c square plus b square. Now let it be equation 1 of v square and let it be equation 2. Now we have to substitute this v square in the v square of this second equation, so it will be b square c square equals v square, and for v square we are going to write this equation, which is e square c square minus m naught square c raised to the power of 6 over e square times m naught square c6 plus b square. And for e square b square c square, e square b square c square, we're gonna get e square c square minus m naught square c raised to the power of 6 times m naught square c6 c raised to the power of 6 plus b square. Alright, now what we are going to do is that we have to multiply this left hand side with this right hand side. And we're gonna get e square b square c square equals, let me calculate, equals 2 square e square c raised to the power of 4 m naught squared plus e square b square c square minus m naught 2 plus m naught raised to the power of 4 times c 6 raised to the power of 8 minus, I'm writing it here, m naught squared b squared c raised to the power of 6. Alright, we got this, and after this things are gonna be a bit simple. You will observe that there something common in the left hand side and the right hand side. There's e square b square c square in the left hand side and e square b square c square again in the right hand side, so we can cancel these terms out. Now we want something for e square c raised to the power of 4 m naught squared. I'm sorry. Alright, you can check this one more time. Hope it's good. Alright, now we're gonna get an equation for e square c raised to the power of 4 m naught squared, which is equals to m naught raised to the power of 4 times c raised to the power of 8, as we know that minus and minus are going to be plus m naught squared b squared c raised to the power of 6, and we have to divide everything by c raised to the power of 4 m naught squared. So we have to divide everything by this term, c raised to the power of 4 m naught squared equals c. These two will be cancelled out, and here m naught squared and it will leave us m naught squared here. C4 raised to the power of 4. Here's C raised to the power of 4. Here m naught squared is going to be cancelled out. 4 plus 2 is going to be 6. C square. We got E square equals m naught squared C raised to the power of 4 plus B square C square. And now we know that for photon its rest mass, which is denoted by m naught, is 0 for a photon. So if we place this 0 here, we will have E square equals 0 C raised to the power of 4 plus B square C square. And as we know that if you multiply any number by 0, you're gonna get 0 plus B square C square. And if you add anything by 0, you get the same thing again. So E square equals B square C square. Now we got this equation. Therefore, if we remove the square, we'll left with E square equals BC. And for P, which is the momentum, we're gonna get momentum equals energy over the speed of light. Regal, get away. Alright. She was my budgie. 1 minute. I'm sorry. You can note it down again. Hope it's clear. And from Professor Max Planck's equation of energy of a photon, it says energy of a photon is equals Planck constant time its frequency, h nu. So we can place this equation in place of E, h nu. And you know the equation of speed of light, it says it's equals to lambda nu, which is the wavelength times its frequency. So we have to put this again here, lambda nu. And now we have to cancel both the nu. My budgie is disturbing me. Oh no. Wait. Now after cancelling both the nu, we are left with the momentum of a photon. Therefore, momentum of a photon is equals to Planck constant over the wavelength. P equals h over nu. Finally, I derived the equation, and my budgie was continuously disturbing me. She was standing on the screen and she many times paused the video, and I'm sorry for that. And many times I was just engaged in calculating rather than also focusing on the screen. I'm sorry for that, and hope you understood the video, and thank you. Meet you again. Bye.
So I'm gonna